C2, Trigonometry, Section 2, Example 2. So here we're asked to find the area of the shaded segment, given that theta is equal to 1.2 radians. So this here is 1.2 radians. And the r is equal to 5. So this is 5 and this is 5. So we need to find the general formula for the area of a segment in terms of r and theta. So if we have the area of the sector, which is all of this part here, then we have that this is 5, this is 5, and this is 1.2 radians. So from the first page, we can find the area of this sector by using a half r squared theta. So we will have a half of 5 squared times 1.2, which is equal to 15 centimeters squared. So then we can go on to find the area of the triangle part. So area of the triangle, where the triangle is like that, where this is 1.2, this side is 5, and this side is 5. So we're finding the area of this part now. So we can use what we learned in sine and cosine rule booklet and do a half AB sine C to find the area of a triangle. So that's a half of 5 times 5 times sine of 1.2 radians. And making sure your calculator is set to radians, you can type that in and you will come out with 11.65049 centimeters squared. So to find the area of the shaded sector, all we have to do is subtract these now. So the area of the segment is equal to 15 minus the 11.65049, which gives us 3.34951 centimeters squared for the area of the shaded segment. So we need to find a general formula for finding the area of a segment in terms of r and theta. So what did we do? We did the area of the sector minus the area of the triangle. So we did a half r squared theta minus a half AB sine C. But in terms of what we used here, AB were both the radius, so that's r squared, and sine C was actually sine theta. So we did a half r squared theta minus a half r squared sine theta. So we could take a half r squared out, and we would just be left with theta minus sine theta. And that would be a general formula for finding the area of a segment.